Hi, my name is Sita Meng. In Project 2, I created a spatial database about the Great Lakes and generated database diagrams. Next, I will introduce what I do in every step of the project and demonstrate my database. First, let's log in the SQL Server and find my database. Yes. In step 2, I imported data of city, country, and lake files and appropriately adjusted the data type of every column. Also, I set name as the primary keys for each of these three tables and check allow nulls in all fields except name. In step 3, I updated the tables by using SQL queries, including for the country table, I inserted Turkey and its data. And for city table, I updated the capital fields of Delhi to yes and inserted Ankara, Brasilia, and Ottawa as the capital of Turkey, Brazil, and Canada, as well as Detroit. For the lake table, I added a new column, continent. Among the countries listed, the United States, Canada, and Nicaragua belongs to North America. Therefore, I set the continent value for all lakes in those three countries as North America. In step 4, I built a relationships between city, country, lakes, those three tables, and created the database diagram and connected the foreign key in country in the lake table to the primary key name in the country table. Similarly, I connected in country in the city table to name in the country table. And in step 5, I used the SQL queries to find the answer to the questions. For example, in 5a, I used the queries to list countries whose population is less than 100,000 in order of decreasing population. After executing the query, we can see the results set successfully. And to answer the question 5b, I listed the names, areas, and depths of the of the lakes in North America in order of decrease in depths. If we execute the query, yeah, we can see the result set. And for 5D, to find the names and the population of capital city of the country where Lake Nipigon is located, yeah, I executed the query and found that the capital is Ottawa and its population is. And for 5E, I found the number of the average depth of the lake in the country of the capital cities. Here, yeah, I excluded St. Petersburg because historically St. Petersburg was the capital of the Russian Empire from 1712 to 1918. However, Moscow is now the capital of Russia. Therefore, I updated the capital field value for St. Petersburg in the lake table to null to avoid affecting the query results. And the other thing I noticed is in the lake table, the depth of Cedar Lake and Small Area Lake are minus 999. That may indicate missing values. Therefore, I updated those values to null to avoid biased results. After handling this, I executed the final query and get the results. In step 6, I created an intersection table named shore to break out the many-to-many relationships between lake and country. I made 3 columns: in country, on lake, and shoreline. Yeah, I selected both in country and lakes attributes. I selected both in-country and on-lake attributes as primary keys. Then I created 2 relationships. First, I connected in-country in shore table to name in-country table. Second, I connected on-lake in shore table to name in lake table. And in step 7, I inserted data of Lake Erie, Lake Huron, Lake Ontario, and Lake Superior according to the barometric details from the given Wikipedia link in the instructions. Because these lakes are in both the United States and Canada, therefore I set their in-country fields as null. In step 8, for the shore table, I used SQL queries to enter the Great Lakes shoreline information in the United States and Canada. Then I created a new database diagram of the table of lake, country, and shore. We can see the shore table acts as a bridge between country and lake, resolving their many-to-many relationship by recording the Great Lakes names and the shoreline length in both countries separately. And in step 9, I used the SQL queries to answer the following questions. Question 9b wants to know the names of the in alphabetical order of Great Lakes that have shorelines in both Canada and the US. So I use intersect to get the intersection of Lake Canada and lakes in the United States. Executed the query, we can get the results. Question 9c wants to sort them by their shoreline length in the US. We can see the result shows the longest shoreline in the US among those 4 lakes is Lake Superior, whose shoreline in the US is 1,000 miles. And in step 10, I imported the Great Lakes 2024 text file. Next, in the lake table, I created a new column, WKT, which means well-known text and shape for the textual and graphic representation of shape. In step 11, I imported the Great Lakes 2024 shape text into the lake table. And finally, I query out the lake table for the lakes in North America. In the spatial results, yeah, we can see the maps of Great Lakes in WGS 9084. These are my project 2 database. Thank you for your attention.